a sprawling industrial town instantly deserted.
Whatever happened here happened very quickly, and it was very bad.
An engineering triumph destroyed in minutes.
It's a great story to be told there, and there's something remarkable to go and see.
And a daring mountain route that swayed the tides of war.
I mean, given the extraordinary engineering feat that it is, this road should be better known.
Once, they were some of the most advanced structures and facilities on the planet, at the cutting edge of design and construction. Today, they stand abandoned, contaminated, and sometimes deadly. But who built them, and how, and why were they abandoned? Located in the heart of Pennsylvania is one of the great triumphs of American engineering. Towering above the forests is a massive engineering endeavor. This now abandoned bridge stands over 300 feet off the ground, runs for nearly 2,000 feet, and uses some 1,500 tons of steel.
This thing was so audacious. Kinzua Bridge became known as the 8th wonder of the world. For a couple of years, it was the highest bridge in the world and one of the most incredible engineering feats.
But just how challenging was it to build such a monumental structure across this cavernous gorge? And how did it become abandoned?
Looking at the ruins of a bridge like this really makes you appreciate just how strong and ductile steel really is.
When steel became available on a large scale, it became cheap to produce. That was the new shiny material that everyone wanted to build their structures out of.
In 1882, the Phoenix Iron Company is trying to build a railway through Kinzua Gorge that will carry coal trains to the Great Lakes. And the solution to the problem is the Kinzua Viaduct Bridge. When it goes into operation, it's the highest trestle bridge in the world. But this audacious project first soars over the gorge with the primary material of its time, wrought iron.
Wrought iron was the go-to material for these kinds of structures. It was strong, it was much lighter than building bridges out of stone or brick, and it was much more versatile.
Wrought iron was very typically used at the time, and looking back at the photographs of what the bridge looked like then, it does look incredibly fragile and quite skinny and slender, but it worked.
The speed at which we can run our trains depends on the power of the locomotive. Where a fill would be too great, we build a trestle or viaduct to carry our trains on stilts.
The original wrought iron supporting columns of the viaduct are radical for the time. The hollow design provides strength with less weight. The bridge's manufacturers, the Phoenix Bridge Company, assert that the hollow columns can support a structure 1,000 feet high if necessary, and over 3,300 tons of weight.
The original wrought iron design of the Kinzua Bridge, with its quite spindly, fragile-looking legs on all the towers that hold up the railway, can be quite deceptive. What was clever about it is making sure that all of the members, all of the constituents of each of those towers were only put in compression. And that's where wrought iron does its job very, very well.
But during operation, engineers discovered trains going over the viaduct cause such vibration through the narrow columns that their speed must be limited to just 5 miles an hour. So they grapple with strengthening the entire structure.
It was mainly coal that was being taken across the top. And as the Industrial Revolution was happening across the States, business, commerce dictated that more coal needed to be transported around. And so the loads that were being taken by the bridge got bigger, got heavier, got much more stressful for the wrought iron underneath. So it was at that point the decision was taken to replace what was made out of wrought iron with steel.
Iron with different amounts of carbon in it can have wildly different properties. So you get cast iron, for example, which is very, very brittle. So I compared that to biscuits, which, you can just kind of snap. And wrought iron, on the other hand, are a bit like the really soft chocolate chip cookies that, you pull and they're very kind of crumbly and soft. And then steel is somewhere in between those two properties.
Wrought iron and steel both come from the same beginnings, iron ore. The difference is the process in how they're made. And wrought iron is much more primitive. If you were to look at the surface of wrought iron under a microscope, you'd see it's quite granular. It's got imperfections in there. It will snap if you try and bend it. Steel, on the other hand, has a much more ordered structure. So if you were to try and bend that, you will get it to bend, and you'll have to get it a long way before it eventually fails and snaps.
By 1900, the Phoenix Bridge Company wants to keep the coal trains moving safely. So, the old wrought iron columns are torn down and a new steel structure is quickly put up in its place. When another iron-built bridge, called the Quebec Bridge, collapses in Canada in 1907, the engineers believe that the Kinzua's new steel foundations will save lives.
The Kinzua Bridge was the brainchild of the Phoenix Bridge Company, an offshoot of a company that made cannons. So they took one technology, long tubular cannons, and said, hey, we can turn that into long tubular support for a bridge. But this is the same company who in Quebec in 1907 built a bridge and 75 people died. So it wasn't exactly a good reference.
So why is the railway abandoned? And what causes the new steel bridge's spectacular collapse? Lying out in rural Pennsylvania, the 300-foot-high Kinzua Viaduct is one of the great triumphs of American engineering. At the turn of the 20th century, engineers replaced the wrought iron leg columns with steel, so this trestle bridge can handle heavier trains with bigger cargo. But despite this upgrade, doubts about its safety continue.
Crew of only 40 men were able to rebuild the bridge in steel in 90 days. Imagine that. But they did that because they bypassed the task of replacing the anchor bolts. That would have taken much, much longer and would have cost a lot more money.
They redesigned the towers right from the top all the way down to the bottom, giving the whole bridge the ability to take a larger capacity across the top. But they failed to change one component, which is possibly one of the smallest components of the bridge, the anchor bolts, which fix the towers into the ground.
So what we had at the base were these wrought iron anchors, which weren't quite long enough to connect the new steel bridge above it down to the foundations. So what they did was put a little coupler piece to join together wrought iron to the steel.
They also included some upgrades, installing small roller bearings at the bottom of some of the feet of the towers on the east side, which is where the prevailing winds would come from, to allow a little bit of flexibility, just so that they weren't on those anchor bolts holding everything above down into the ground.
But despite this significant flaw, the Kinzua Viaduct safely supports countless trains for the next 80 years, until local coal supplies finally run out. Then in 1959, the Commonwealth of Pennsylvania turns the bridge into a visitor attraction.
In the 1960s, it was really unusual to take a decrepit old railway and turn it into a tourist attraction. Nobody had done that.
So then, what causes this behemoth to fall? On July 21st, 2003, a full-blown tornado slams into the eastern face of Kinzua Bridge. 94-mile-an-hour winds tear at the steel support columns on their stone bases. The result is devastating and reveals the bridge's Achilles heel.
So we had these wrought iron anchors, and they weren't quite long enough to tether down this new steel structure above it. Then, when the wind came in and pulled this bridge upwards, this coupler split. Just wasn't strong enough to do the job.
Once those wrought iron anchor bolts had just been overstressed and had sheared, snapped off, the bridge then is no longer attached to the ground. The bridge effectively got picked up and started to be moved around by the wind, which is an incredible image to think of this man-made structure becoming alive almost in the wind.
In less than 3 minutes, more than half of the Kinzua Viaduct becomes a mass of twisted wreckage. Incredibly, no lives are lost, but the historic structure that had stood for so long lays in ruins. Instead of demolishing the remains, the state of Pennsylvania leaves the fallen columns and rail bed where they lay. Today, from a newly built public viewing platform, visitors can see the wrath of nature's fury.
There's a great story to be told there, and there's something remarkable to go and see and feel and be part of. It's all there in front of you to see, the disaster and the devastation that this wind has caused. But more than that, for engineers, there's a case study here, and there's something to be learned for future projects. If you're gonna replace wrought iron with steel, do all of it.
5,000 miles away, out in the remote pine forests of Ukraine, at the heart of the infamous Chernobyl exclusion zone, lies one of the greatest achievements of the Soviet Union. This abandoned city spreads across 5 miles of land, has 150 buildings and 60 modern roads. It could house a population of around 50,000 people. It was one of the most technologically advanced cities on the planet. But today, it lies derelict and deserted, patrolled by armed guards and protected by security barriers.
The abandoned city is a modern-day Pompeii. It's as if overnight, or at least even within hours, life changed. You see a huge wheel where the local community would have recreational moments. You see children's toys. You realize that whatever happened here happened very quickly, and it was very bad.
So what happened to this city? Where did all its residents go? And how was it abandoned? In 1970, the Soviet Union is in a technological race against the West. To power its global ambitions, the country creates the Chernobyl nuclear power plant. But this cutting-edge facility requires tens of thousands of people. And to house these nuclear workers, Soviet planners build an entire city called Pripyat.
It's very easy for us now to look and think of it as a disaster town. It's linked intrinsically with the nuclear disaster just down the road at Chernobyl. But I think you have to look at it as how it was intended and how life was before disaster struck. The iconic images that we can picture about Pripyat, the Ferris wheel that's kind of stuck there and decaying, and the gas masks lying around, that tells one story in this, just looking at decay. At the time, when it was operational and it was functional, that was the Soviet dream, and people wanted to be part of it.
Though only open to those with government permission, Pripyat is designed to provide state-of-the-art housing to its residents. Despite the imposing modern architectural style, the city is designed for families, and lots of them.
The city wasn't finished till the very end, and all the construction had been pre-planned. This was a blossoming city, and it was the first place I'd seen in my life. There had so many roses and kids around.
In a remote, dense forest, the city's planners have almost unlimited space for their new town. Without the restraints that come with expanding upon a pre-existing town, they impose a utopian architectural vision and construct a completely new, modern city. They build wide avenues for cars and public transport, as well as numerous parks and gardens between the apartment blocks. And as most of the city's population are under 30, there are plenty of sports facilities.
You've got these high-rise buildings, which normally had been used for areas of high density, but yet each building is hugely spaced out with these enormous green areas in between to give people space. I think that would have been very new and very quite unique even, and maybe it was an identifier as, you know, this is the new way, this is how the new Soviet communities are going to be. Pripyat was iconic at the time.
The heart of Pripyat is its main square.
Right now we're in the central square, and this building right in front was the so-called cultural building. It was named Energetic. And to the right you can see this was a hotel. It was called Policia. At the time of the explosion, it was a very high-tech and contemporary hotel. And over there, on that 9-story building, there's an emotive slogan that says, "Let the atom be a worker rather than a soldier." And that's how this whole thing turned out.
With Chernobyl only 3 miles away, why and how quickly is the city of Pripyat abandoned? Over the course of 15 years, the restricted city of Pripyat swells to nearly 50,000 people. But at 1:23 a.m., on the 26th of April, 1986, only 3 miles away, Chernobyl Nuclear Power Plant 4 releases a plume of radioactive debris into the atmosphere. A huge area covering the Ukraine and neighboring Russia is contaminated, and radiation levels increase dramatically across Europe.
Reactor number 4 exploded, spewing radiation over much of Europe. 2 others have been permanently shut down. It is the world's worst nuclear accident.
The brand new city of Pripyat is now subsumed in a deadly radiation cloud. But to prevent embarrassment about this closed city and the secretive Chernobyl plant, the government publicly hides the disaster, even to its own residents. Within hours, many start falling ill. Yet amazingly, another day goes by before the authorities evacuate the city. But then, hundreds of buses and trucks pick up Pripyat's inhabitants. They are told they would only be leaving for a few days.
The layout at Pripyat, with its enormous, wide avenues and big open spaces, in my mind, certainly helped the efficiency of the evacuation that took place over 48 hours. Getting the entire population, almost 50,000 people, away from that town. If you tried to do that in any kind of conglomeration that had grown organically with little streets and back roads all over the place, that would have been a lot more difficult. It would have been one heck of a challenge.
Within 48 hours, the inhabitants from Pripyat and the surrounding area are evacuated, never to return.
Having structure and being able to, I guess, break it all down and plan that evacuation, and then having the arteries to get people away, just made that whole evacuation work really quite efficiently. It would surprise me if the successes of what happened at Pripyat when disaster struck, how quickly they managed to evacuate the entire city, wasn't used as best case analysis for future disasters.
Today, Pripyat remains restricted, but for an altogether different reason. As part of Chernobyl's exclusion zone, this abandoned city is regulated by the state agency of Ukraine.
The irony is that the whole place has now become a very popular tourist attraction. Why? I think it's that morbid fascination. We've been watching too many B movies for decades now. You want to see in the real world what could happen on a larger scale if we get it wrong big time.
Rotting away amidst nuclear fallout, Pripyat silently screams a warning of how quickly utopian dreams can become haunting nightmares. A 1,000 miles away, carved through the top of the Italian Alps, is one of the most terrifying engineering projects ever built. This 4-mile-long road snakes across the sheer mountain cliffs 6,500 feet above sea level through a network of 52 tunnels blasted through solid rock.
You've only got to walk on it today to see what a hazardous undertaking just moving along it would have been. Forget about actually building it in the first place when there's literally nothing in front of you.
So why would anyone build a road through such an insanely dangerous place? In 1916, World War I is ripping Europe apart. Italy is with the Allies, fighting against the Austro-Hungarian Empire. But the Austrians are invading Italy through the Alps with the aim of sacking Venice.
Well, most of the fighting the Italians do during the First World War is in the mountains that border Austria-Hungary. As a result of this, it's known as the White War. Of course, in many cases, they were actually fighting above the snow line. The logistical challenges that presented and the natural, formidable obstacles that mountains are to the movement of military troops meant that there wasn't actually a lot of gain on either side.
To cut off the invading army, the Italians must get troops and supplies to defend Venice. They brace for a final stand at a strategic strong point 6,500 feet up on Mount Vesubio.
Monte Vesubio was of vital strategic importance because it represented the last major obstacle between the Austrians and the Venetian plain. If they get beyond that obstacle, there's nothing stopping them advancing towards Venice, and if they do that, they cut off the vast majority of the Italian armies who are fighting on the northeast front.
Their desperate solution is to construct this. the perilous 52-tunnel road.
You're working on the side of a rocky mountain. You've got fairly basic tools to work with. You're trying to explode into the side of this rock and take material out. And you're creating what ends up to be quite a narrow path, enough for 2 mules to pass on, that it just had to get done.
It can often come down to engineers to make the impossible possible. No, it can't be done is not an acceptable answer.
But will the Italians construct this road in time to save Venice? And why is it abandoned? To beat back the Austrian army during World War I, Italian engineers must construct a perilous road through the top of the Alps. Their plan is audacious and desperate. Blast a 4-mile road through the tunnel's mountain peaks in record time. The result is the 52-tunnel road.
1 million soldiers were pitted against each other. 600,000 Italians up against 400,000 Austrians. The Austrians advanced from that side, and by taking the mountain, they hindered the use of this road, which the Italian soldiers used to get to the front line. This is why the 52-tunnel road was made.
It's hard to understate just how perilous this engineering project is. Engineers must face high altitude, violent storms, and heavy winter snow. But despite the dangers and risks, they battle unbelievable odds in trying to make it happen and face death every day. Can they do it? Or are the obstacles too great?
Those are the times when engineers have made what might seem impossible possible. Under attack, at altitude. It's an amazing engineering achievement and should be recognized as such.
But constructing the 52-tunnel road isn't just dangerous. It must also be made under extraordinary time constraints.
The whole road was built in 9 months at altitude with limited resources, and it will have saved thousands of lives.
With only 9 months, the Italians rely on what was then cutting-edge technology, heavy explosives, and a powerful new tool, the jackhammer.
Jackhammers, or pneumatic drills, came about in the late 19th century. And when it came to tunneling and road building, it made the whole process so much more efficient. Previously, it was physical labor with chisel to break away the rock or to make holes to drop explosive charges into to blow your way through. A jackhammer is effectively a hammer and a chisel combined. Using compressed air, you can hammer away really, really quickly at that rock face.
In the tunnels, you can still see all the holes created by the drills, which would have been filled with explosives. The explosion would then enable the construction of the tunnel.
During this grueling and war-torn process, hundreds of engineers perish building this mountain road. But will the Italians' engineering efforts actually save Venice? And why is the 52-tunnel road eventually abandoned? Carved atop the Italian Alps is one of the most terrifying routes ever built, the 52-tunnel road. During World War I, Italian engineers used jackhammers and explosives for 9 grueling months, to blast a 4-mile-long road through the solid mountain rock. But despite the loss of hundreds of lives, the plan works. The road gets the Italian army and its supplies through the Italian Alps, where it beats the Austrians back to save Venice, helping to turn the tide of World War I.
Maybe it's not as well recognized as it should be as the feat of engineering for what it is, considering the conditions under which it was done.
I mean, you have nothing but extraordinary admiration for the men who did it. And were they recognized with bravery medals? I suspect not, yet they probably should have been.
In 1918, the Allies win the war. But after its service in the First World War, and after several major accidents and deaths, the Italian army abandons the 52-tunnel road in 1936. Today, the road is in a shambles. Though it's officially still open to the public, only the most determined hikers scale these heights.
I think this pathway, which now tourists use all the time to walk on, it's really important for engineers to remember that times like that come and go without us really expecting it. And it might be that during my lifetime or my children's lifetime that engineers will have to come up against that sort of pressure again. And we need to remind ourselves that, you know, right now we've got the time and the luxury of really thinking through stuff and designing things very well. But what would it actually be like to do something like the 52-tunnel road in times of intense stress? I think it stands there as a reminder to us today that things aren't always quiet and don't have the luxury of time always.
But the men who built the road also left a memorial to their colleagues who died and to their backbreaking efforts that helped turn the tide of World War I.
I think the engineers achieved a huge amount in that very short space of time. So where they've got this beautiful ornamental concrete arch with their motto, it's justifiable.
The work is so great, they chose to write the following in Latin: Ex Ardis Perpetuum Nomen, which means the names of those who make great works will be remembered forever.
On the other side of the Atlantic, near Washington, D.C., lies the remains of what's called a ghost fleet. Here in the shallow waters of Mallows Bay, Maryland, just on the edge of the Potomac River, are the remains of over 200 steamships. Some of them extend as long as 300 feet. And they're all made of wood.
It is a fabulous ghost yard. When the wind is coming offshore at an extremely low tide, we still discover new vessels we weren't aware were still down here. Once you can get the lay of the land, it makes more sense than when you first look at it and just see this jumble of rotting wood. There is a real inherent logic to it and an amazing story.
But why were these ships built? Why were they abandoned? In April 1917, the United States enters the First World War. For the previous 2 years, her factories had been producing military equipment for the Allies. But now they must face the daunting task of equipping America's own forces.
Was the U.S. prepared when it entered World War I? No, not really. I mean, the reality is, their industry was at full capacity, making armaments for the Allies.
The entire American industrial base had been turned over to supply munitions to the British, the French, and the Russians. The Americans had no spare capacity, and they certainly weren't ready to fight.
But despite that, there's a far more pressing problem.
They were really challenged. They couldn't keep up with sending supplies to the Allies in Europe, and it was a real problem.
If we're going to enter the war and not only get supplies over to the Allies, but also our own soldiers, we're going to need an awful lot of shipping. So how much shipping do we actually have? Well, as it turned out, not enough, because this extraordinary order goes out to create 1,300 feet wooden vessels that would do that job.
Keeping the supplies going to Europe results in one of the greatest shipbuilding projects in history.
With the advent of World War I, there was a proposal made to come up with something like 2 million tons of shipping in 18 months. Phenomenal proposition. They wanted to build 1,000 of these wooden steamships. They were not military vessels. It was a civilian endeavor. There were support vessels. The problem was they were 270 to 300 feet long.
But because the steel foundries and major shipyards of America are already pushed to their limit, ordering 1,000 steamships for delivery so quickly is asking the impossible. So the U.S. government must take a step back to the construction techniques of a previous era. This means building with wood.
In 1917, the American steel shipbuilding is not a very large industry, so the Americans see the quick way of building ships is to go back to the craft industry and build in wood, because that's going to be quicker than trying to set up new steel shipbuilding centers.
There were 8 basic designs that were issued, and every shipyard kind of tweaked them based on their own mastery of it. No one knew in 1917 when the war was going to end. It wasn't in the foreseeable future, so 18 months was extremely expeditious to try and get 2 million tons of shipping out to answer a badly needed call.
But are the U.S. shipbuilders able to handle this tremendous order? And why is this unique supply fleet eventually abandoned? In 1917, the United States enters the First World War. To supply their troops in Europe, the U.S. government commissions 1,000 steamships to carry arms, armaments, and supplies to help the war effort. But to keep the cost down, engineers make the supply fleet out of wood. But there's another important reason to use this material.
They were largely expendable, so if you're facing U-boat action, you'd rather lose a wooden hull quickly built to a metal hull. Although we certainly didn't want to lose the supplies. It was keeping the economic supply chain open that was critical.
Contracts for building this giant fleet go to 87 shipbuilders across America. The project is hailed as a unique and war-winning triumph for American construction. But just how difficult is this massive engineering effort?
I think this sudden need to create 1,000 ships from a marine industry that really isn't geared up for this does smack of desperation.
They built them very fast. They had problems with green timber. They had problems with them leaking when the vessels were launched. The vast majority of them, about 127, had triple expansion engines. If you want to think about the Titanic, that's very similar. The rest had variations on that. They had problems with vibrations. So some of these vessels, when we get in among them, you'll see there are large blocks of concrete. The tips of the metal you see protruding here are part of what we call the composite structure, where it's been reinforced in a crisscross pattern. These were added to help stabilize the vessels. They were patchwork, if you will.
But reverting to wood construction has an unexpected consequence.
The shipyards that they go to aren't big enough. They don't have the resources. Many of them have lost their ability to build ships effectively in the previous few years. So the industry that in 1900 was still fairly dynamic is on its last legs.
They are asking people who really simply don't have the means, the tools, and the expertise to do a job that's probably beyond them. And so it proves, because not a single one has actually been used for transporting either men or materials across the Atlantic, which was the original purpose.
Additionally, alterations to the ship's designs caused the costs to spiral out of control. Producing each one costs the modern-day equivalent of a whopping $22 million.
When these shipyards were underway and in full flight during the beginnings of this effort, America became the greatest shipping nation in the world because it's not just building boats. It's cutting lumber. It's building the machinery for the engines. It's extracting the metals. So it was employing a vast number of people who weren't directly involved in the war effort, but certainly were directly involved in it at home.
Though America helps the Allies win the war in 1918, it takes almost a full year before the United States government finally cancels the wooden fleet, leaving more than 200 unwanted ships. There's only one thing to do: abandon the entire project and scuttle the fleet.
The whole project ended up being a grand example of what happens when you go into something completely unprepared, make hasty decisions, and throw lots of money at it. It's a classic modern democratic government problem.
The majority of them were moored across the river near an area called Widewater, and they'd take a few at a time up to Alexandria to have them broken down for the metal components. Some of the wood, mostly the metal. But because of storms and fires, every time there was a problem, they'd break loose, they'd become hazards to navigation, they'd sail downstream. So they tied them all together, burned them to the water line. Here they are, and here they remain.
Today, the disaster story that has turned Mallows Bay, Maryland into a massive naval scrapyard has become an extraordinary and unexpected success. The 200 rotting wooden ships lying in the water now form part of a huge nature reserve, providing a refuge for ospreys and waterfowl.
So we have 1,000 wooden ships commissioned at $1 million apiece. Is that American can do or American should not have? Today, they're an ecosystem for wildlife. But what is that? That's the most expensive nature reserve in history.
But what was once a costly military mistake is now an ecological success.